In this lesson, we're going to look at simplifying radicals with the factor tree method. Our essential question is, how do you simplify a radical expression so that it is in simplest form? So let's define simplest form. A radical expression is in simplest form if the following conditions are met. There are no perfect squares other than 1 in the radicand. So let's make sure you know what a perfect square is. Perfect squares are 1, 4, 9. Where am I getting them? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49, and they go on infinitely. Now, what's a radicand? If I have a square root sign, in general, this is known as a radical sign because we don't only have square roots, we have cube roots, etc. The number beneath the radical sign, that's known as your radicand. Okay? So there are also no fractions allowed in a radicand. And we also can't have any radicals in the denominator of a fraction. So we will look at how to get rid of this bottom case, actually the second two cases in the second video today. So let's look at how to simplify the square root of 32. So when you do this, one thing that's good to check is make sure that this is irrational. If I type it in the calculator, and I encourage you to make sure you can do this, I get a decimal 5.657 rounded. It goes on infinitely. It's irrational. That is not what simplify means, okay? We need to write this as the product of a coefficient and another radical where we break it down. So the easiest way to do this is take 32 and make a factor tree. So any two things that multiply together to give me 32. If it's a prime number, my strategy is to circle it. 2 is prime, 8 breaks into 4 times 2, and 2 breaks into 2 times 2, and they are both primes. Okay, once you have all primes, I pair it up. Okay, I have a pair of 2's. So that's going to go outside my radical. I have another pair of 2's that also goes outside my radical, and I have this one lonely 2 left over. That stays inside the radical. I can multiply these 2 outside to make this 4 root 2. Now, a way to check this is toss 4 times the square root of 2 in your calculator, and you will get 5.657, the exact same decimal, so you know you simplified it correctly. Also, when I look under the radical sign at 2, the only perfect square that is a factor of 2 would be 1, so I also know that it is simplified. Practice with 450. So this breaks into 45 times 10, 9 times 5, and 5 is prime, 10 is 2 and 5, both of these are prime, and 9 breaks into 3 times 3. So again, I'm looking for pairs. Why pairs? Because I'm taking the square root. And just, think about it, the square root of 3 squared would be 3. They undo each other. Okay, so I have a pair of 3's, so that's going to go outside. Square root of 3 squared is 3. I have a pair of 5's, so that's going to be on the outside. And what's left over? I've got this 1, 2 that's not in a pair, so it stays beneath the radical. I multiply the 3 and 5 together to get 15 root 2. A good thing to do is toss both the original root 450 into your calculator and 15 times the square root of 2 and make sure your decimals match. You're going to encounter some radicands that include variables, so I start by breaking down 9, and hopefully you already realize that the square root of 9 is 3, but if not, you get 2 3's, so 3 comes outside the radical. Now, x cubed, I'll list it out, okay, but eventually you'll get faster at this and you realize, oh, so I have a pair of x's, so one x comes on the outside, and the other x, this lonely one, stays inside. One more before it's your turn to practice. So 48 breaks into 6 times 8. 6 breaks into 3 times 2. They are both prime. 8 breaks into 4 times 2. And 2 times 2. Okay, so I'm looking for my pairs. I have a pair of 2's, so 1, 2 comes on the outside. I have another pair of 2's, so another 2 comes on the outside. And I have a leftover 3 that stays inside. Now I go to the variables. I have just one a. I can't take the square root of a, so I'm going to leave that under the radical. B to the 5th, well, that means, let's look at it, I have 5 b's as factors. So I have a pair that comes on the outside, I have another pair on the outside, and then I have one left over on the inside. So if I multiply out coefficients together, it would be 4b to the 2nd times the square root of 3ab. Okay, it's your turn to practice. Pause the video, practice, press play when you're ready to check your answers. The second thing I'm going to show you in this video is how to apply the product property for radicals. So it says the square root of a product equals the product of the square root factors. A little bit of a confusing statement, but easier to see illustrated right here. Okay, so if I have the square root of a times b, I can separate that into 2 separate square roots. So why does that help me? Well, if I've got numbers, take a look at this. Square root of 4, x can be written as the square root of 4 times the square root of x, and if you know that the square root of 4 is 2, it helps you simplify. So let's use the product property here. I don't know the square root of 6, it's irrational, but I can put these separate factors together to make this root 36, and I know that the square root of 36 is 6. In this one of the things I always say in class is it's important that you realize you can multiply radicands together and you can multiply coefficients together. So what are my 2 coefficients? Well, right here it would be 1. So I'm doing 1 times 4. What I highlighted in pink is 4 times the square root of 3x squared. Well, 3 is not going to break down, but x squared, I can take the square root of x squared since it would be a pair. One of them comes outside, so it's 4x times the square root of 3. So again, in this practice problem, I'm going to multiply coefficients together. So again, it would be 1 times 3, which is 3, and then I'm going to multiply my radicands together, which would be 147x to the 2nd, y to the 2nd. So I'm just going to break down this radicand. Now I just multiplied 7 times 21, so I know it's 7 times 21, and then 3 times 7. So I have a pair of 7s that's going to come out on the outside. So I had the original 3 that was out front, times 7. Open up a square root sign. This 3 stays inside. Then I have an x squared and a y squared. Since they're pairs, they each come out as x times y. So my final answer is 21xy times the square root of 3. Your turn to practice. Press pause and then check your answer. Make sure you complete your practice problems. The only way you're going to feel confident about this is if you try it yourself.